Welcome in, everybody. How's everyone doing today? Yeah, I swear to God, this happens every time. Yes? No? There we go. Hi, everybody. I'm back. So sorry about last week. Sunday, I was on a trip, and I wasn't able to stream. But, hopefully, maybe, theoretically, should be at least one stream a week on Sunday. Hopefully. But, yeah, no, it's regular. Right. Is there anything else? No. Yep, we're just working on the same project as last time. Um, I will give a quick description of it. Hopefully the music's not too loud. Looks fine. Obviously, if music is loud or if my voice is quiet, like, can I turn this up any higher? That doesn't go any higher. Um, yeah, if the music is loud, just let me know. Quick summary of the project. The idea is okay. Let me grab out paint. Nope. Step there. Okay. Pathing. A lot of the times you hear pathing is in the term of like games. Is like you have a guy. You need him to go to, I don't know, here, here, and here. How do you get him to do that? Well, you can say, I don't know, go here, here, here. Straight lines. My lines suck. Don't worry about that. You can tell them to go in straight lines. There's a line tool, isn't there? There is. Line. So lines, right? Cool, lovely. Lines are pretty accurate. But that doesn't look great if you animate it, because he'll just kind of go here and then he'll make an instant turn, and then he'll go there and he'll make an instant turn. It doesn't look great. So, well, fuck it. What if it's a curve? I think this is a B-spline. Oh, yeah, it is. So what if, well, instead of doing that, um, we had him do curve stuff. Lovely. Wow. And you know, if you were good at this and an artist, you could get it to, fuck, you could get it to make curves that look nice and smooth. And so that's kind of the idea, doing that, but programmatically. So in code, actually, never mind, cancel. I'll probably use this later. And to do that in code, and then you can represent different paths. So paths, you usually hear it like that, but they can be any kind of line so that you define as a function of some time. Usually it's time t. Not always, just some input, and it gets you some output point in space, something. Theoretically, you could have a path that gives you a point in like 7 dimensions if you really wanted to. Essentially, it's a way to go between one kind of a starting point and an ending point, whether that's space, uh, other stuff. I can't think of them. Another way you'll see that is like states. No, not like country states, but like if I have, I was thinking about this recently. I'll explain it. Rectangle. So I have a synth, right? It produces nice sine waves. Lovely. I'm just gonna draw it freehand. We'll see how it goes. It produces sine waves like this, right? So it produces whatever nice sine waves. Cool, lovely. What if I want the sine waves to be longer? Well, then I make the frequency shorter. I make the frequency smaller, so there's less sine waves in a whatever second. Nope. So now maybe the sine waves are like super long, or like if I want to make the frequency, if I want to make the sine wave super tall, then I make the amplitude. And so all of those numbers can be represented as a state. And now if I have a state, and I want to get between two states, well, I can use a path. Because I could just go up to, like, in a straight line, but maybe that doesn't sound super smooth, so maybe I want to make it a curve. Right? A bunch of different applications of paths. It isn't just the actual path itself, like, in space. Anyways, so the idea, you have a bunch of objects that represent a path, and then you can take that path and you can combine it with other paths, apply effects to the paths. That's what I have this mask for. Jesus Christ, there's so much I'm gonna need to fix. So you have a bunch of objects. You can apply effects, you can combine them, you can do whatever you want. And then you can either like render them or you can dump them to a file so that you can import them elsewhere. I don't know. All of that's a bunch of features. There's a lot of features that I eventually want to get to. We will probably not get to all of these. Because I'm a lazy motherfucker and I don't feel like it. But, you know, in theory, if I had an infinite amount of motivation, this is where the project would be headed. We'll see how far we get. Now, that puts us, where are we? What the fuck? Where does that put us? I changed a bunch of stuff about how it works. We were working on this last time. I think I lost the plot a little bit. So, because of that, we didn't get very much done. So the plan today is to not lose the plot. I know. Crazy. And to do that, I have this to-do list. And first, what we're gonna do, also, I think we have ads. Like now. There we go. There's the ads. There we go. Yeah, I'll explain a little bit more when everyone comes back from ads. But the idea is that I'm just gonna build like a to-do list kind of first. What's this? Oh. No. I'll edit the markdown myself, thank you. What's up here? This, and then to do. So this is stuff that needs to happen later. Semantics? That's not the right word. Side shit. No. Details. Whatever. Good enough. Change add string, and what was it? It was format. Nice. Cool. So we got to this. Oh, we did actually get some stuff done. I think we did min samples, which I need to test. Okay. Oh, and then documentation. I need to redocument everything. Because I think I specifically removed all of the documentation. No, I didn't. That was for a different one. Yeah, I'm working on multiple projects. Well, I work on multiple projects at the same time. I have one I work on stream. This one, it might become two if I get distracted and decide that I want to do something else. Because that happens. Nope, not that. It's this. Just go here. Oh my god. But I have another one that I work on at home and in class when I don't feel like paying attention. And so sometimes I'll get stuff mixed up. Okay, ads are over. Yeah, what I was talking about is to hopefully not get as distracted and to actually get stuff done. We're gonna make a kind of like to-do list anytime things need to get done so that we don't immediately start working on them. And we can finish what we want and then go back and look at the to-do list and see what else we have to do. What was this? Document. Everything. Documentation. I have one is because I think some of this has documentation, not all of it. Okay. So to do that, right, we were working on the typing stuff. So for base path, what is it? Default equals. Do we do that? I think is start T, end T. Actually, that doesn't help anything. I don't want to have a whole bunch of variables, so we'll just leave that there. That's fine. Good enough. Let me give you the precision type and this. Right. So this is the thing we need to change to actually utils. Main. Oh. Oh, fuck. Right, okay, yeah. So that is what we need to do next. Design. No, not entirely. It is this. Better exception system for safe type cast. Oh. Oh, it is. I didn't know that. Better exception system. Not exception, it's a warning system. And I just need to stop building that because this is taking way too much time. Yeah, I'm gonna figure that out. So we'll put that into to do things that we need to do, and do we want to? Nope. We are going to just get to the I can np dot vectorize, I think. Okay. So value is a scalar. Where's types? Types is here. Okay. No, so we have path scalar, then we have a collection of these. Then we have ND arrays. Okay. Wait, here, yeah. Wait. This is the fuck, am I an idiot? Because that is how that works anyways, right? You take a okay, fine. Tuple, happy. There we go. So it has to be a tuple or type. Okay, cool. Yes, okay. Value is an ND array. And what do we, I guess, vectorize? Wait. Oh, convert type. Is there anything new here then? There will be, I guess. So we'll just kind of prepare for that. hoodoo, like that. That's how you spell that. One day when Italian is done, we'll take our leave and go. Yeah, yes, we should. So, if it's... I guess we can also just... Can you reference yourself? I don't think so, right? Wait, no, but if I do this below... Give me a sec, pass. It's vec safe deep fast, Jesus Christ. Equals np dot vectorize safety test. Vectorize gives me I don't need this then. Fine. Oh, you just deleted Annie, I think. Did we use Annie? Yeah, we did. Oh wait, no, you kept it. Then you want to organize imports. Value type. Oh wait, turn. I think that's how that works. Let us test. Def add to a return a plus 2. What? Yeah, fuck you. Vec add to a equals, wait, no, equals p dot vectorize add to r equals np dot range 10 and okay, I mean, like, exactly. Okay, well, what if it's typecasting? Oh, wait. Equals r. Does it? Wait, no. It is. That's what I meant. Is this... Okay, so they are different objects, because, like, what if I do, for example, np dot... You take a D type, right? D type equals float 16. Np dot float 16. Np dot return np dot as, wait, a dot wait, that fuck it, np dot float 64a and it's not what add2 does, but you know, it's fine. Okay, so for example, if I make this int, this is still fine. Now if I make this float 64 like this, you have a step. Step equals 0.5. np dot return int. Do you? Oh, okay. np dot int 64. Okay, so it does actually work. You are allowed to change the typing. Dot. Oh, as type int. Is that the way you're supposed to do it? If you put an int in there. No? Yeah, okay. So as type does what? Oops, we moved it over there. Cache replacement. Yoink. Let me turn on the music again. Playlist. Stream music. Yeah, that's fine. Okay. So it is a copy. Oh. Oh yeah, then I don't even need to vectorize it. I just use as type. Oh, wait, no, and I don't need to vectorize it then either? Yeah, but let's, for example, what does as type do? I don't need this. P dot float. Does as type work vec like that? Float up, and that's fine. Okay. So if it's an array, you just don't. Okay. No, you still need to check for what depends. No, if it's an ND array of ints, ND array of ints isn't actually int objects, right? ND array of ints, int objects, or converted to np int 64. Okay. Well, I guess let me test something again. As type int dot d type. Okay, now I add 2. Okay, so it is an int64. It does just auto converts. Good to know. Because otherwise the d type has to be object, right? Okay. Utils. What? Wait, no. We do this as a, what kind of operation? If it's an ND array, then we need to check if the requested output type is bigger than the, no, wait, smaller than the requested input type, right? So then do we just check? We can take each and we can check it, or because NP has vectorized operations, we check for a couple of things. Does NumPy have a specific unsigned numbers? uint 32 with 31, uint 32, uint 64. I think there's a 16 too. No, I think we already looked at this, right? Yeah, okay, so it's just in integers. And what do we say about types? Features can go away, I don't know why that's still up. It is any integer, any floating. The problem with, I guess, int is it's not really a problem. Okay. Wait. Int is instance int np.integer. False. np.int 64. Oh wait, no. Type of np.integer. In is not right. Yeah, no. I guess let me just. I think if I just do like 2, I put that there, then it'll work. But it's the type itself that isn't right. Because I'm asking if this isn't in. Yeah, and you don't like this. Why don't you like this? Jar type list. Okay. Oh, because you have n-bit and int. This doesn't work, yeah. Fine. Then how? I guess a good way to check types, you just need def check type. I don't have a check type already, no. Because I assume I thought of this problem before. It's always how this goes. It's like, yeah, wait, no, I know exactly why. I remember thinking about this, and I just forgot what I decided to do about it. Check type. What do we want? We need a type and a cool. Hi, Ash. How's it going? It's been a while? Yeah, it has. I'm doing all right. Um, just um frustrated working through stuff like always. Did I ask that? How have you been? I forget. It's 1:30 in the morning. You're about to hit the bed when you saw a notification. Well, I really appreciate you popping in, but you should you not be in bed? You got a rare old fishing license. The fuck? Oh yeah, I remember adding that. 56 anchors, 107 total. Nice. Working on the same project we've been working on for a bit. The like a pathing lines with code. But right now I'm working on making sure that you don't that if you take like a decimal number and you turn it to an integer, you know that you're gonna lose some of that precision. We need an input type, and we need a type that we're checking against. Or I guess we have our out type is what? Just any path scalar. We just we just kicked the can down the road, I guess. But it's fine. If we're going from YouTube, yeah, I have a YouTube. Yeah, it's just VODs and stuff. I wanna like everything. I wanna start editing videos to put up there. But I ain't got no time for that. At least right now. So probably when this quarter ends, then I'll have a shit ton of free time. And I'm just waiting for that to happen. Fuck, that's so far away. It's only been, what, 3 weeks? We have in type is a what? Type of path scalar. Out type. Oh wait, no, we have in value. I guess it depends, really. We'll see. I think that logic might have to be pretty specific to each thing. No. Value p dot nd array of np dot integer. No, no, I'm not allowed to do that. Okay. Yeah, I know I did that already, so it doesn't matter. But I'm gonna check if it's. Do I guess I just check against every D type? Okay. If value equals. Wait, no. Dot D type. np dot int 16, I think, is the lowest we can go with. You don't have an 8. Oh, you do have an 8. Damn. 4? No. 8. Wait, a short isn't a print is instance np dot short 4 np dot integer, right? Fuck. Oh, there's so many more things I need to check now. P dot types. What are all of the actual types? Okay, so np dot bool of like 0. This is none. Okay. So we don't have to check bool. A bool is just one. A byte? Really? Why? Why would you store it? Okay, I don't get that. Because bools are usually stored as numbers. It's usually 0 or 1 for on and off. Or wait, 0 is false, 1 is true. And I was a little bit worried that they were gonna say, yeah, bool is an integer. Like, no, nah, doesn't count. So a bool is non-integer, and int 64 is uint 8, or int 8, uint 8, int 16, uint 16, int 32, uint 32, int p. What? Uint p. Uint p. Yes. Well, yeah, it is. But do you keep that d type? Okay. And int p does the same. It just picks the biggest one that you're allowed to use. Fine. That's okay. Character code only Python API C-like name. What? Guaranteed to hold pointers? Guaranteed to hold pointers without sign. Oh, okay. N32 or N64 np.long. Okay, so this is a byte, a U byte. Oh, okay, so they all have so they're all int, so this is int 8, uint 8, int 16, uint 16, int 32, uint 32. Fine. Int 8 is, well, I mean, I guess let's just see. np.int 8 of 2 to the power of 8 equals 2 to the power of, okay, wait. Let's try 4 first, right? You should be able to hold this many numbers. Okay. Now, what if I ask you to hold a lot more than that many numbers? Okay. Whereas a uint 8 can hold this. No? What the fuck? 7? So you can hold 7. You also can hold 7. What the fuck? Then where are the extra 2 bytes going? Or bits? But whatever. So you can only hold 6. Is that it? Or I guess it's 1 extra bit. Wait. 0. This is 2 to the 0, 2 to the 1, 2 to the 2. Oh, that's fine. Never mind. I'm an idiot. Wait. Not in value. If con type equals should I? Yeah, I should put this in a separate one. Def check cast and the array. Wait. And the array. The value is np dot and the array. Wait, no, we were there, but it's fine. It's a path scalar. Path scalar. You don't actually return anything, so this is fine. If np dot any is the way that you do this, right? Yes. Value greater than wait, because you store, yeah, so you store this minus 1 should be fine. 7 minus 1 is fine. Yes. Okay. Greater than int 8. This is what, 255? Oh, 127? Yes. Wait, con x equals con type. Wait, no, I can't use them like that. That's fine. empty dot integer, unsigned integer. There we go. Do we want to just ignore any unsigned integers? Because I can then specify this further in types to be any unsigned integer. Yeah, no. Wait. Yeah, no, this doesn't work, right? np dot int 64 equals np dot integer. There's no way that's okay. That's false. That's what I thought. Oh, x instead. Wait, no. Equals np dot okay, wait. This is dumb. Let me just and int list equals np dot uint 8 16 32 64, yeah. And int list float list float 16 32 64. Fine. And unsigned. Wait, what? Oh. Yes. In it's not actually types though. It's just util stuff. Wait, what? And instead of this, it's this, and this is, wait, 2 to the power of 8 minus 1. Oh, we should put this down like that. 2 to the 16 minus 1. 2 to the 32 minus 1. To the 64 minus 1, and then we just do the same operation here. And close this. This is 2 to the power of 7 minus 1. 2 to the power of 7 minus 1. Nope. 2 to the power of 7 wait, not 7. This is 15. This is 31 minus 1. Nope. 2 to the power of 63 minus 1. Yes, I think. Transcendence. Wait, no, it's external warn. Casting. Type 2. Here's the D type. This is value dot D type, and this is just font type. np dot any value greater than intended of type. Casting value type of font type. in place. Signed in place. Same process here. The pain np dot all if not np dot all value dot as type type I just have to make sure that that actually works. R equals np dot range 10 step equals 0.5 t type equals float print r dot as type int equals r and r dot float 30 float 16 as type float equals r. Should say wait p dot all np dot all. So it should be true or false true. Good. That works. see. Expel issue val count empty dot count on 0 count this. Yes. Yeah, no. Please continue playing. Expels is value of we'll do this, except because of how this works. Of 0 through either min 3 shell count. Wait, like this. Oh, wait. What if it's, yeah, because if it's multi-dimensional, then this kind of just breaks. How to get first. Oh wait, no, it'll just return as a list, right? Flatten. Flattened view of car. I don't want to actually flatten it. That. Okay. Fine then. Dot ravel value dot ravel. Wait, no. I want to use property notation. Flat value. And right now. For okay, fine. Entire job is to be a good cache, so just def simple cache def init. Wait, self dot get, wait, not def, this is class self string. Condition. This is a callable. Callable of item to any. So it doesn't restrict it at all. Get if return self dot value. What self dot condition is self dot value? No. condition. What? My God. Okay. This. Okay, happy. There. Simple cache. Oh wait, I should switch the order of those. That should be. Cache. Wait. Oh, by the way, because this can go at the end because then I can set it equals none. Value dot revel and x is none. Okay, no. Any equals none. Any. Value dot get. Of 0 issue count. It's either 3 or issue count. X files. wait, no, it's do this, and that, no x like that, and then x values. Yes, yes, I think so. Cool. And then it's this same issue, but now it's unassigned. Wow. Just test this real quick. Callable from collections, any from typing, and that's it. Cool. Wait, no, def get val. Return 2. Simple cache is get val. Oh, get val. And it was lambda x is 1. That's what we did here. We did x is none. Yes. And dot get wait, oops, that's not a print. That is just a thing you do. Oh, right. It's right, you just treat it as a property. Value. So I should just call it value then. Wait, no. Val.val. Oh, look at that. Okay. Utils is simple cache. This should be called val. And then you just treat it val. Not any. Wait, oops. This value dot val. It's np dot is close is probably better. Np dot is close. Wait, no. Close np dot random. This is random substicks for porting to the new random API. Okay, no. Range step equals 0.00. I think this should be fine. So like that. As type equals np dot float 32. Wait. Dot all r dot as type p dot float 64 equals r. So going up is always fine. Okay. There's no weird things that happen. Okay, but if you're going down, we have float 64, but then, I don't know, this is like this big, and you're going down to 32. This should, no. Okay, I don't know actually how well 32 handles things. Okay, so this is why. There's np dot okay. Let's R. Let's, I don't know, like 2. Print. So it's different. 39. 36. But these aren't the same. NP dot all. False. Okay. I assume it's just all of it, right? Yeah, besides the first one, they aren't equal, even though they are basically equal. Oh, wait, maybe that has type np dot float 64? No, still none at all. Like, for example, if I do this, what, huh? Oh, well, this is weird. Just because it's printing those digits. But also, how do you do, I guess, NP dot is close with relative tolerance? NP is close rel tol? What is that? Because I know NP dot all close. Absolute A minus B is less than A tol times R tol times absolute. Okay. So then we just use this, not like this, but something like that is close. And E, oh, what is it, -6 is usually standard? Or -6 is standard. Then R total equals 1, E -5. Dot all. It's just a thing, and that'll give you one value. Wow. Okay. Oh, -9. Wow. Okay. So you use rtol, and then atol specifically kicks in for zeros, but for zeros they shouldn't change. So we just don't even need to include atol at all. Okay. That's good to know. NP dot all close. -6. Oh, I should just take a tolerance. And what do we accept tolerance as? That's a base path. What do you accept? Oh, precision. Why would I not? I... Yeah, I don't know. We'll just leave it the way it is, because it works. No, it's a bad way to do it. Precision fits. Yeah, it's fine. This is... Oh, because I want to put it at the end. Nah, it's fine. Tolerance, float. Equals 1e -6. One, 6. All right. Total is this tolerance. Count here. Count 0. Oh wait, is close. Not. Flat value dot val instead of value. Flat value dot val. Flat value dot val. Yeah, that's fine. X files, downcast warning, and we just close it. Hmm. Oh, yeah, no, this is just has to be, because there's no altitude. And then we would just return value dot as what's the hell? Yeah, no, just this. What is out type? It's a path scalar. So it's type returns. I think it is. So I don't know, because it is the same. Out type is a path scalar. And, oh wait. Oh wait. Okay. Well, I guess we don't do this then. This needs to be a path scalar, and it really isn't. Path nested scalar. Yeah, no, that's fine. What it isn't already being isn't always happening. Yeah, I know. This is a path nested scalar. We just have to type path scalar, and you aren't used anywhere, so it'll go away. What else can a path nested scalar can be? It can just be a path scalar. And if it is, then we just trick. Same thing, but equality. I guess. Do you need this much detail? I don't think you do, right? No, we'll do that. Yeah. So if it is not the same, but it is greater, then we also ignore it, because we already did that one. This one is you just do this, copy it. Value. Wait, what? Oh, no. Like this and this. That's fine. Broken because of that. Now it's fixed. Wait, no, stop. Grab this. Grab this. Okay, happy, chill. I think that's alright. Cool. Yeah, that's fine. Just add warning. Finish warning system. Use event as logger. What types? So we're a path scaler. And right. So for a collection is instance. Which collection did you import? Import from ABC. value. Oh wait, no. Lambda. Oh, if in float int type of x oh, wait, no, I guess we'll just do the, oh no. With that's kind of like the end option, so tuple. What else do we have? We have elif is instance. No, not ND or A. ND arrays, no. Wait, it might actually be a collection. Nah. Value set. Alright, I have to go to the bathroom. I will be right back. Where's be right back? Right there. Yep. See you in a bit. Alright, and we're back. Wait, save deepcast X and contype. Map equals to go here. Like this. This map. If this instance value top else try no I'll turn list of rest map. We already did end the array. Oh my god. Wait, yes. No, it is on here. So why do you want to do end the array again? Path scaling. What do you not like? Float. Wait, no. It just needs to be a path scaler. Instance 2 path scaler. No. Fine. And float. X equals int float np dot integer np dot floating. Path message scalar types equals int float and then a collection These should all be completely portable because that, except for collection. Collections ABC. And then, well, never mind, it might not be as portable. There, fine. This instance to path scalar types. Yes. Okay. Path nested scalar. Oh, because it includes. Oh, I know. It does work. But even though that's a collection of, it's still fine. Okay, well, great. To think I am perfect. Path scalar types. Oh, well, I guess then it just must be. Great. The thing you complain about that, and then you complain about that, but those are all fine, I think. Value can't be none. If its value is an integer. Wait, why do we have an out type still? Thought I got rid of that. Value. Sends value int. Oh. This was a dumb way to do this. If like that. Flat dot val. Lovely. Oh, should I do that separately? Yeah, fine. Negative. What? Oh wait, this is unsigned. Oops. Let me grab this one. Plus a negative. Plus a negative. Plus a negative. Trunk value. I can spell. Place works. Values. Close that. Oh. Alright, I need to go grab something. I'll be right back. shit, was my mic off that entire time? Alright. Quick, we have a couple seconds. Thank you so much for watching, I really appreciate you. Remember, take care of yourself, dying is fact bad for your health. There's the socials, Discord, YouTube, VOD will be up on YouTube, Discord, live alerts, announcements, stuff like that. And if you want to chat with me, I'll stream. Yep, dying is bad for your health. Remember, take care of yourselves. Drink water, eat food. I will see y'all next time. Bye, actually.